Hi Moo. You had a video here about what I'm going to call evolution versus industrialization. A philosophical debate. Actually, I just wanted to clarify something. Obviously, kind of serious evolution, like the new species style kind of evolution. Homo erectus and Homo habilis versus Homo sapien. Obviously, that happens very slowly over hundreds of thousands, if not millions of years, right? So that kind of macro new species kind of evolution, I don't think can directly counteract the effects of something that's happened so fast and so quickly in human history, namely industrialization, which I think is really what you were talking about there. Um, but obviously, but at the same time, I don't want to discount it. I mean, there are short-term versions of evolution too. Obviously, like it's exactly what Charles Darwin observed at the Galapagos Islands. I think the order of magnitudes of of those time spans were only like 500 years or something. But I mean, even shorter periods of time can see smaller amounts of evolution. So, but you see, industrialization has such large impacts on humans, and such swift impact, whereas evolution, I think, is just too slow, right? To be to that directly um, counteracted. So your question really is, uh, uh, well, I'm going to split your question into two parts, and I'm just going to focus on the effects of industrialization on humans. Um, so, okay, first of all, your examples, I just want to sort of clarify a bit. I mean, taller people comes from better nutrition. That is to say, I mean, we're herding cows and we drink milk all the way through our adolescence, so that gives us access to calcium, which lets our bones grow. I mean, if we get rid of the calcium in our diet, uh, back to like pre-herding of mass herding of cows and drinking of milk, I think we would lose our height. We would get short again. And the number one reason for the increase in cancer is the decrease in every other disease, right? The thing is, the reason why there's more people dying of cancer is because they're not dying of tuberculosis or malaria or something like that, right? So basically, in general, people are going to die anyways, and they got to die of something. And we don't have cures for either cancer or heart disease, right? So heart disease is the other one. Um, so both of those as causes has increased over time for the simple reason that other things that could have killed you we're getting better at getting rid of, right? So, um, but I don't want to discount your examples at all, because if you just switch them to more obvious examples like diabetes, autism, mercury poisoning, and attention deficit disorder, there are no those don't have simple explanations, right? The rise in those things is that's I mean, if it's not industrialization, I don't know what it is, right? That's caused all these things. Um, so the underpinnings of industrialization is um, really the concept of exponential growth. So uh, basically, the idea is that in industrialization, you want to sustain a constant rate of growth in whatever, in food production and population or whatever, and that has the side effect of leading to exponential growth. I mean, that's really the side effect of industrialization is it's allowed us to sustain much larger populations. Um, and populations always grow exponentially until they hit some equilibrium point. Uh, we've decided we're so good at industrialization that we're not hitting an equalization point, and this is a bit of a problem. Um, but there's a thing about exponential growth is that it always inevitably has to stop because there's some finite constraint somewhere along the way that gets violated. Now, I've written down like a couple examples here. The one is kind of a conspiracy theory nonsense, kind of like the whole peak oil business and running out of oil thing. And I mean, the problem is it's too mired in conspiracy theories to be taken, like, for me to explain it without people calling me a conspiracy theorist. But there is an underpinning behind it called Hubbert's peak and stuff like that, Hubbert's curve. I'm just going to skip that example because it's too controversial. However, one that's not controversial at all is something called Moore's law, and this has to do with your computer. The entire computer industry is governed and completely leeches off this one thing called Moore's law. Moore's law basically states that the performance of your computer or your processors that can be made, or a state-of-the-art processor, is it doubles every 18 months. So the speed of your machine doubles every 18 months. This is why there's always newer and faster computers coming out. And the industry relies on this, right? Because they want you to think that your computer is old so that you can buy a new one. Because there's going to be some new capability they're going to sell you, and it requires more processing power. For example, the mere ability to record yourself live on a webcam that required a certain level of performance in your underlying processor before that could even be possible. So, anyways, the point is Moore's law has been with us since the very beginning of the industry and is with us right until today. The thing is, Moore's law appears to have ended. Prominent people in the industry whose vested interests are in seeing Moore's law continue have themselves now publicly spoken out and said that Moore's law appears to be dead. And there are technical reasons. I'm a computer geek. I understand that a lot of people may not want to listen to all this kind of geeky stuff, but I don't know how to avoid it. The point is there are technical reasons why Moore's law failed, and I have to expand on them a little bit to really make it clear what's going on here. With each, what happens is processors are made out of a silicon process in which they have to solve certain material science problems to improve the performance. They make the feature sizes smaller, the transistors smaller basically, so they can put more transistors on a chip. But they also have to make sure the signal integrity remains good even as they get smaller, right? And every time they do that, in order to do this from generation to generation of manufacturing process, they have to solve new material science problems every single time. And if you look through the papers of these people and on who talk about this sorts of thing, you hear all these things like silicon on insulator, low-K dielectrics, copper interconnect, and shallow trench isolation. These are all techniques that these materials that they have of material science that they have to. Anyways, the point is that each one of these techniques is like a kind of a hack, a sort of desperate attempt at pushing the boundaries of where they can go. And what they've discovered is these hacks have they don't keep going. They run out of steam. And we're now at a point where one of the primary problems, I think, I believe, is voltage leakage, and microprocessors simply can't be solved anymore. They've sort of run out of tricks, right? They've done every single possible workaround, and now they're at the point where there's nothing obvious left. Making the clock rates in microprocessors of single microprocessors is just, you can't do it anymore. So Moore's law appears to have ended. I mean, it might not have hard ended yet, right? But I could stand here, or I can sit here, but before you and say that we will never see, for example, a 100 gigahertz processor. We simply won't see it. That's it. There's no way, right? Even though Moore's law says that we should see something like that. If Moore's law continued, we should see something like that in less than 10 years. I'm saying no. We'll never see that, right? And that appears to be what has happened. So that's a case where, the point is Moore's law is an exponential law was with us for so long, and although there's always been naysayers even about Moore's law, we've always forged ahead, and the whole industry's has been built on this assumption, right? And I don't know exactly what's going to happen in the future. We're now going to multi-core CPUs, but that's whatever. That's not the same thing. So that was a very long example. Sorry for anybody who's probably bored out of their minds by that. But so all exponential curves essentially eventually have to, you run out of something. That's the problem. Like some finite constraint just gets you. So, uh, and industrialization has essentially enabled exponential growth of population, and has led to exponential food cultivation is required as a side effect of that, and exponential uses of energy. I think that's pretty clear, right? Energy is used by people, and China's making that a little bit scary right now. So yeah, I mean that's a real problem, but it's a problem we have to solve as a society outside of evolution. Evolution isn't going to help us, right? Evolution is too slow. I think we as a society just have to solve it. Um, but I want to bring this back to evolution, though. I mean, um, you ask whether a genetic disease will eventually get us. I mean, because that's another thing that we're seeing. And I'd say, as a primary example, we should think of AIDS. How did AIDS happen? I mean, what do you think about that? I mean, personally, I think AIDS should have wiped us out. AIDS itself, the disease, but it didn't, and there's a simple reason for that, and it's because we're smart. In order to combat AIDS, we had to figure out AIDS, and then we use various approaches like abstinence only. That's as we know, that's so effective. Well, anyways, no, but seriously though, we use more serious techniques, and AIDS is probably not going to wipe. AIDS is not going to wipe out the human race, but it's because we're smart, and so that's what really makes us unique. Is that from other animals? Is that we have great intelligence, and our intelligence is a really active part of what we are. It's really makes us unique, and it allows us to escape the intelligence has allowed us to escape Mother Nature. Essentially, we set our own rules now, but at the same time, you made that quote about fighting nature. Mother Nature is kind of useless because Mother Nature always wins, and I would like to just say, well, yeah, I mean, fighting Mother Nature is like remember the vertex thing? It's like the vertex fighting the scissors, right? I mean, you know, we don't have alternate sources for water, air, or soil that Mother Nature doesn't provide for us. So, fighting Mother Nature, it doesn't make sense. We'll kill ourselves, and then Mother Nature will rise again, anyways. So, from that point of view, I think that those sorts of problems are really sociological, and they're outside of evolution. But I want to bring us back to evolution, though, because assuming we solve all those problems, assuming we don't blow ourselves up, long-term evolution is a really interesting philosophical question for me. If we come back to the AIDS example, apparently, and I've read this somewhere, I don't know how credible this is, but um, people from Europe who survived the Black Plague apparently have a higher than usual immunity towards the HIV virus, or towards HIV, which means essentially they're immune to AIDS. And that's really interesting. Uh, it means there's literally a breed of humans that can survive AIDS who has better immunity. So, as I said, I don't know the exact how good the data is on that. I just read a story on that. So, but certainly that is suggestive of how evolution can affect us. That there are certain superhumans, essentially, that will survive. That certain things like AIDS or like viruses, right? I mean, other animals really don't threaten us at all. Maybe mosquitoes. I don't know, but viruses, right? Those are our real enemies. Those are the guys that will challenge us, and evolution suggests there then that those that have greater immunity would survive. But I'd also like to posit a kind of theoretical kind of mutation that humans might cultivate. Like, let's say, for example, at some time in the future, we have calculators embedded in our brains. Like some mutation causes a calculator to be embedded in our brains. I mean, that would be really useful, right? Because today, I mean, you think of how people deal with numbers as, everybody hates math. Not me, but, and that's a bit of a problem, right? Um, it means you can go to the grocery store, and if somebody screws up, fraud can easily happen, or or not even the grocery store, but anywhere, fraud can happen because you can't calculate what the price of something is correctly, fast enough, or whatever, or you just calculate wrong or whatever. So that would be an interesting evolution, for example. And long term, such things might happen. And we see actually examples of that today in autistic savant, like higher functioning autistic savants, for example. They can like multiply 15-digit numbers in their heads and stuff like that. How does a person do that? Well, unfortunately, autistic savants usually have other problems, sociological. So, but you can see how evolution is sort of working its magic there, and that sooner or later maybe we're going to find people that have little bits of autistic savantism in them that enables them to have these higher functions without the detrimental effects, and then that could be and obviously those kinds of people would be higher functioning, and I guess they would just have much better survival rates. I guess you would imagine that such a person. These people would tend to be natural leaders, or just more valued, I think, in society. Anyways, this has been a bit of a ramble, but you brought up some interesting ideas and questions, and I just had to chime in. Anyways, those are my thoughts. Do be later.